Hello guys. So today we are going to discuss about the fundamental understanding about the machine learning. Okay, let's go ahead. Okay, so this session objective is after this session you will be able to understand how machine learning can be used to solve in real world and what are the different types of machine learning algorithms and the framework that we use to build the machine learning models. Okay, and how Python can be used in building machine learning models and the importance of Python. And there are different types of libraries that are available in Python to build the machine learning. Okay. Uh, as I said, the real world examples, like we have a different types of industry sectors: healthcare, finance, marketing, manufacturing, and autonomous vehicles. So these are a very few, and we also have a lengthy list where we can use machine learning. So if I talk about the healthcare, in a healthcare, machine learning is going to identify a new drug. Okay, you can discover a drug that will helpful, and you can diagnose a disease. And in the finance sector you can you can detect a fraud. When we are doing making online payments, it will detect the fraud. Okay, and also it will identify our algorithmic trading. And in the marketing section, it will help us to identify the customer segmentation and the targeted advertisement. The manufacturing industry, you can predict the maintenance, okay, and the quality control. And in autonomous vehicles, I hope you might have heard pretty much about the self-driving cars, where Uber is already providing the services to the customer. The self-driving cars, driverless cars. Okay, this is one of the best real-world example. Okay, so we start with basic a use case and try to understand the machine learning. Okay, so we use a recommender system. So what exactly is a recommender system? Okay, so recommender systems use machine learning to suggest items based on the user preferences. Okay, if you wish to buy any mobile, a particular model, okay, after choosing that mobile, then in that e-commerce platform, the intelligence of that app product will give you some recommendations. Those who already uh, purchased a similar kind of models, where not sure which model is good, which model to buy. So you will see that recommendations. Okay, so then if you purchased a mobile, then what is an add-on that you can buy where other customers are buying using the similar kind of a product. Okay, uh, and also the other examples where you're already much familiar with Netflix, Amazon, Spotify, YouTube, and any other social media platform. Okay, so in the Netflix platform, when you're watching a particular genre movie, okay, let's say you are watching uh, a horror film. Okay, so that horror genre film will have again many different uh, factors, like based on a hero, based on a director, based on the music director, artist, right? So there are again the subcategories, right? So if you're watching, then it will recommend uh, the similar genre movies. Okay, similarly in the YouTube, if you play something, any audio or any video, then it will give you the recommended to watch. But this is going to help to the end users to simplify their selection. This is a best example where we can talk about the artificial intelligence in their application. With the help of the machine learning, they are recommending a similar kind of a model, similar kind of a movies, audio, video. So where we don't need to search pretty much, and we simply choose one of those if we are fine with that recommendations. If not, we will follow our own search. Okay, so let's try to understand the analytic word. Okay, because we use the artificial intelligence, machine learning, and deep learning to create some value from the data. Okay, because for all these things you need a data, and from the data you analyze something, and from the analysis you will predict something. Okay, so simply analytics is a collection of techniques and a set of tools and the concepts. Okay, why you do analytics? To create some value from the data, what data you have. Okay? Because from the data you create the analytics. That analytics will help us to predict some outcome. Okay, yeah. So now let's understand the basic, the generic definition. What is artificial intelligence, machine learning, and deep learning? So artificial intelligence is a set of an algorithms and systems that exhibits a human-like behavior. Okay. Like you see a robot, like so that is having some kind of a human-like behavior. That robot will have an artificial intelligence in its body. Yes, it's a machine. Okay, the robot is a machine. That machine behave like that will have an artificial brain. So how it is having an artificial intelligence with the help of machine learning and the deep learning. So machine learning is a subset of artificial intelligence that enables computers to learn from the data and improve their performance on a specific task. So we'll see an example in the next slide. Okay, so the deep learning again, it's a subset of a machine learning. It imitates a functioning of a human brain to solve the problems. Okay, so how we generally do a machine learning? Okay, so we have a different classifications: supervised learning algorithm, unsupervised learning algorithm, reinforcement, and evolutionary learning algorithm. So now let's look at each individual. So supervised learning. So let's take an example. Okay, imagine you are teaching a child to recognize different animals because initially they don't have any knowledge in their initial days. Okay, so what we do, we show them a picture of dogs, cats, and birds, and we label each picture. Okay, over period of a time, the child learns to identify these animals based on their features, which is an ant, which is a cat. Right? This is essentially what a supervised learning. Okay? So in supervised learning, algorithm is trained based on a data set. So what do you mean a data set? Okay, so data set, you will be having uh, an image, okay, and with the same label. Okay, so each data point, okay, this is a car, this is a motorcycle, and this is a truck. So each is a data point. Okay, so each data point has a corresponding label or any target variable. Okay, so supervised learning analyze these label examples, then the algorithms learns to predict the correct label for a nuance in data. Okay, so then it will compare these two, and then we use that model. Okay, yeah, now this is a truck, this is a car, and this is a motorcycle. Let's take another example. Okay, so you wanted to predict house prices. So you want to build a product so that will based on the location. So a person wanted to sell an apartment. You don't know what is the price, the sale price uh, at that moment. So you can utilize a machine learning to predict his value of his property. Okay, what information is required to predict house prices? Okay, you need to have a labeled data set. So that labeled data set consists a collection of houses. That houses have each with the features like square footage, number of bedrooms, location, along with their corresponding sale prices. Okay, the previous sale history of the houses. Okay. And what you need to do is you need to take that labeled data so that the algorithms learns how these features are related to the sale price. So we need to train on the available labeled data set. So once you train, then your algorithm will predict the given a new house with its features. Algorithm can predict its likely sale price. So and what price you can sell that house. Okay. Now coming to the second algorithm, it's a classification unsupervised learning. So unlike supervised learning, you don't have any labels or instructions. Okay. So let's take an example. So you have a pile of mixed ties. Now you need to sort those. Okay. So what do we do? Instead of we group toys together, we separate them based on similarities like size, shape, or color. Either it is a sedan or it is a sports car or it is a truck. So based on these patterns, structures, relationships in a data set without any prior guidance, we will uh, predict some outcome value. Okay, that is a unsupervised learning. Okay. There is another example. Take an example of a customer segmentation. Okay, so a retailer, let's take an example of Amazon, Flipkart. They wanted to understand their customers better. Okay, so that they will have a better sale if they understand the customer in a better way. Okay, so here they use a supervised learning algorithms to group customers based on, let's say, you take their purchase history, and the demographics, gender, age group, and the other relevant factors. So they use unsupervised learning. And the third one is reinforcement learning. So here, imagine that you are teaching a dog to fetch a ball. Okay, so what you are doing, you reward the dog with a treat every time that it brings the ball back. You're throwing a ball, and you are expecting the dog to bring the ball back, and you are offering a reward. Okay, so over the time, so the dog learns to associate fetching the ball with a positive outcome. Okay, and it becomes more likely to repeat the behavior because that is expecting a reward. So this is essentially concept of a reinforcement learning. So in this reinforcement learning, we'll take the example of self-driving cars. Self-driving cars learns navigate roads by interacting with the environment. What environment? The roads, right? So it takes actions like steering, accelerating, or braking, and it receives a reward or a penalty. If it is taking an action when there is a red signal, and if it is taking an action to stop the car in front of the lane, then it's a reward. If it is a crossing a bit, then there will be a penalty. Okay, so the goal is to maximize safety and efficiency while reaching the destination. Okay, so this is what the reinforcement learning, and the fourth one is evolutionary learning. So evolutionary learning is, imagine that again, you are breeding dogs for a specific trait like an intelligence. Okay, you select the smartest dogs to breed together. Okay, hoping that their offspring will inherit their intelligence because you want to maintain more intelligent dogs. Take a military example. Okay, so they need intelligent dogs. So how you will decide this is an intelligent dog? Right, based on some previous history training, so then you expect a similar kind of a dog. Okay, so that's what the evolutionary learning. Okay, over generations the intelligence of the dog population increases, the similar to how evolutionary machine learning works. It is inspired by the process of natural selection where the fittest individual survive and reproduce, passing on their beneficial traits to future generations. So this, what about the four different classifications of machine learnings? Okay, so don't worry. In our future session, we will discuss more about all these uh, classifications along with examples. This is only just the fundamental understanding of the machine learning classifications. Okay, so now let's try to understand the workflow. Okay, so when you are going to build an AI solution, artificial intelligence solution, so what you have to do exactly, where to start and where to end. Yeah, this is certainly a workflow. This is divided into several stages. So the first thing is you need to identify what problem are you trying to solve. What is your aim? That has to be noted. The problem statement. Okay. Then to solve that problem, so you need some data. Okay. So what kind of a data that you require to solve it? Okay. So once you understand what kind of a data collection that you need, okay, so again the 100% data may or may not be helpful all the time. So you need to identify the useful data or 80% or 90%. Then you need to clean your data so that it will take that accurate data to build the model, so that you will get the nearest predictions. Okay. So once you have the useful data, you will build a model using the programming Python to solve your problems. Okay. Once you build a model, then you have to validate whether the model is solving the problem or not. Okay. So if yes, then you just put that into the production, or you can update to the stakeholder. Okay, this is a kind of a workflow. Before you start any machine learning solution, keep these points in your mind. You need to have a problem statement, data collection, then you need to explore the data, and you have to do a pre-processing, cleaning, and then you have to modeling your solution, and you have to validate, and then take a decision making and the deployment. This is a end-to-end workflow of a data science. Okay. So as I said, um, so why Python is widely used programming language uh, in artificial intelligence or machine learning. So because Python is interpreted and it is a high level, okay, and a general purpose programming language. So Python code is very reliable and it has an amazing ecosystem. So it has a comprehensive set of libraries for data analytics and analysis and visualization. And also this Python programming can be used to build web applications, enterprise applications also, not only machine learning. Okay. So if you want to know more about the Python programming language, please look at my Python fundamentals course. Okay, so this is a simple brief explanation about the why Python is used more effectively in the machine learning. And these are the different Python libraries that we use in our machine learning. One is a numeric Python, which is used efficient storage of arrays and matrices, numerical calculations, a backbone of all scientific calculations and algorithms. And there is a sci-fi library. This is especially for scientific computing, linear algebra, statistical computation, and optimization algorithms. If you wanted to perform these things, then you have to use your the sci-fi library in your Python coding. And you use matplotlib and cf1 if you wanted to do a plotting and visualization. Then these two libraries are going to help. Jupyter is a notebook, an IDE where you can use this to develop the data analysis code in Python. And you have a pandas library which provides a high performance, easy to use for data structures, okay, called data frames. If you wanted to build data frames, then pandas library is going to help. And scikit-learn, if you wanted to build supervised unsupervised algorithms, then scikit-learn is going to use. Okay, this is the pretty widely used libraries in python. uh, that is going to help to build a data science solutions. Okay, so that's all for today, and hope you understood the fundamental knowledge of the artificial intelligence and the different types of classifications of machine learning, and how this machine learning is addressing the real world examples. And uh, the programming that we use is python in our coming sessions. So you should understand the importance of a python and what are the different libraries that we are going to cover in our course. Okay, so that's all for this session. We will meet in our next session. Thank you.